Okay, so again, a question we did from class today, or we're going to do in class, didn't have time. That's exercise 17.41, and it's let's just start from the beginning. Consider the reaction methanol goes in equilibrium with carbon monoxide and hydrogen gas. Okay, we're asked to calculate delta G for this reaction at T is equal to 298 kelvins. Okay. Under these conditions, okay. So it looks like I've got some kind of a reaction quotient that's of interest here. The reaction quotient is going to be the products over the reactants. Oops, it's not concentrations, it's partial pressures. I'm going to leave it as that for now. All right, so we have a reaction quotient, we have a Q, and that's given to us there. Okay, and we have delta G of formation. Let's be formation for a couple of these guys here, and not for hydrogen. Why not hydrogen? What is the standard enthalpy or standard free energy of formation for hydrogen? It's equal to 0, right? Because it's in its standard state. Okay, so we're asked to calculate delta G. All right, and so I'm thinking to myself, all right, delta G is equal to delta G. The delta G of the reaction is equal to the standard delta G plus RT ln Q. And I have already Q. I can get ln Q, of course. I have temperature, and that's a constant. So what I need is delta G, okay, of the reaction. Now, the way that I get that is, so yeah, first of all, I've got to calculate that. That's step 1. And it's right here, right? That's 1. Step 2 is I've got to calculate this delta G of reaction. So the way I'm going to do that is I'm going to say that delta G of the reaction, the standard free energy of the reaction, is equal to, and this is just Hess's law again, right? End products formation minus end reactants enthalpy of formation. This is of the products, right? This is of the reactants. Okay, so we've seen this reaction before. All right, so let's calculate. So if we calculate this, this is the second thing we've got to do. Okay, and that's just by using this equation. All right, so let's go ahead and calculate that. It looks like the products, the energies of formation of the products, are here, hydrogen, which is 0. Oh, I can, 0 plus carbon monoxide, which is not 0. It's minus 162, minus 162.3. This is in kilojoules. All right, and there's only 1 mole of that, so this mole right here goes to 1. All right, minus all of the reactants, which is only 1 of them, only 1 mole, and it is, oops, I have the wrong number in there. This is minus 162.3 kilojoules, okay? That would have been costly. Okay, we'll leave that in kilojoules. This is going to be, the carbon monoxide's 137 minus 137.2. All right, so let's calculate that. Our calculators, it looks like it's going to be, where am I here? That's my cursor. 162.3 minus 137.2, which is, pause the video at this point and calculate it. (162.3 minus 137.2 equals 25.1. And that's in kilojoules, right? Okay. So we got that one. It's 25. We got part 2. Now we just have to calculate part 1. And that is here. So it looks like it's H2 .175 squared times the partial pressure of carbon monoxide, which is 0.125, divided by 0.8. Which comes out to be 0.004785. Okay, that's what Q is. Now ln Q, I'll take the natural log of that, comes to be minus 5.3422. So RT ln Q is going to be 8.314. This is in joules. So to make it in kilojoules, I'm going to go ahead and divide it by 1,000. And the temperature is 298. And this is minus 5.3422. Okay, and so RT ln Q is 13.24, or rather negative 13.24. Okay, so if I put these two together now, this will be, let's see, delta G is equal to the first part, which is 25.1. That's in kilojoules, right? This was also in kilojoules. I made sure of that. This was in joules, but the 1,000 made it kilojoules. Minus 13.24 equals 11.86. Okay, so we'll go back over here and see. This was to 1 decimal place, so we'll say 11.9. Submit that, and we got it correct. All right, hope that's helpful. Just in review, we had a couple steps here. We were asked to calculate delta G, and we've got a couple ways of doing that, but with this information, we were given Q, right? So we calculated Q, and we're given the heats of formation, or the energies of formation, and so, we have to calculate the energy of reaction from the energies of formation, which we did here, step 2. So we calculated delta G from getting the energy of the reaction and adding RT ln Q to it. Okay, hope that's helpful.